Hey everybody. So today we are going to be looping back into Module 5. In Math 3, we perfectly split Mod 5 into Part 1 and Part 2 because we feel like Mod 6 fits perfectly in between. And if you guys did Part 2 before knowing Module 6, we just think it's better for you to learn in this order. So we're going to start here. This whole unit is about trig identities. We've already talked about a couple. For example, that you guys know that the reciprocal of sine is cosecant. That's a trig identity. The fact that you know that tan is equal to y over x, that's actually an identity. So that's what we're going to get into. So we're just going to do the warm-up of 5.6 just so that you guys can kind of refamiliarize yourself with the 6 trig ratios, because it is important that you guys know these very well. So just as a little warm-up, if we have this triangle over here and we're looking at angle R, so that would be this angle. And this is the opposite side, right? The hypotenuse is across from the 90. And then the adjacent is the side right next to the angle. That's not the hypotenuse. Okay? So sine is equal to opposite over hypotenuse. So that would be 10 over 26. And then, of course, you guys would reduce this so we can divide both of these by 2. And that would be your answer. Okay? So that's just the ratio. So, if we're looking at cosecant, well, we already have sine, so we can just take the reciprocal and make it 13 over 5, right? So cosine is adjacent over hypotenuse, so you do 24 over 26 and then reduce. And then the tangent is opposite over adjacent, so you do 10 over 24 and then reduce, and then do the reciprocal, okay? So then you guys may see this kind of format on the ACT or SAT. So if we start here, sine of theta is 5 over 13. Let's draw ourselves a triangle. A right triangle, of course, because that's where you find trig. Theta, you can put theta here or here. It actually doesn't matter, but it is important for you to label your image. So I'm going to choose to put mine down here. So if sine is equal to 5 over 13, we know that sine is opposite over hypotenuse, right? So that would mean from our angle theta, the opposite side is going to be 5, and then the hypotenuse side is going to be 13. Okay? So then you could use Pythagorean theorem to find the third side, which would just be 12. And that's how you'd find the missing side. But then you see this right here. So this formatting is nice because this is always 90 degrees, right? And 3 angles inside of a triangle add up to 180 degrees. So if all 3 of these add up to 180 and one of them is 90, then what do this plus this equal? 90, right? So that's 90 and this is 90, which is 180 together. So if these two together are 90 degrees, on like an ACT question, if this is theta, if they want to talk about this angle, they can't just call this theta, or oh, let's call this x, or oh, let's call this the other angle. The official way to say the other angle is by writing it like this. So if these two add to 90, so I'll put a question mark for now. So if the question mark plus theta equals 90, because 90 plus 90 is 180. And we want to solve for that question mark, so we're going to subtract theta to both sides. And that means that that other angle is equal to 90 minus theta. That's all this means. So this literally is asking you, what is cosine of the other angle? The non-theta angle. Okay, so you might see that writing like that, and that's all that that means. So if we want to find cosine of the other angle, from here, cosine is adjacent over hypotenuse. So as you guys can see, those are actually the same. Sine of theta and cosine of the other angle are equal. Okay. All right, so that was a good little warm up to remind you about trig. Now, if you guys go to Google Classroom, because it's not included in the packet, I posted what did I call it? Like a trig identities rule and strategy, or even like a identities cheat sheet, one of those. I somehow misplaced mine, and my printer isn't working, so I just wrote my own, but this is what it's going to say on Google Classroom. So you don't need to write this down. You can just pull it, or I mean, you can write it down, or you can print your own from Google Classroom. But so this is basically our guide to this module. You can use this during homework and on the test. If we were teaching at school, we would first give you guys like a blank one of these and just have you fill in some of the blanks to make sure that you knew them, and then you would be given this on the test, but we're not going to do that. You might see like some questions on the test, kind of like fill in the blank, but yeah. So let's start with the reciprocal identities. So these we've kind of already talked about before. So like, remember when sine was equal to just y, or y over r, or y over 1? So that's why cosecant is its reciprocal, 1 over y, right? So that's why you see these two as reciprocal identities. So sine and cosecant are just reciprocals, they flip. Same with cosine and secant, and tan and cotan. So because these two are equal, we can replace one with the other, right? It'd be like saying, it'd be like me giving you an equation like this, and then, oh, if x equals 3, then what does this simplify to? So because these are equal to each other, you can replace x with 3, right? Substitution. So that's exactly what we're going to be doing in this module, a ton of substitution. So we got to be comfortable with that. So this is equivalent to that. So if I see a sine, I can substitute it with 1 over cosecant because they are equivalent, all right? Sometimes you're going to see thetas, sometimes you're going to see x's. It really doesn't matter. Let's move on to quotient identities. Just give me this. So in quotient identities, this is when we said like tan equals y over x, right? So we already know that because of what we solved on the unit circle. So if sine is equal to y and cosine is equal to x, then by substitution, here's a trig identity. This is called a quotient identity. Tangent is equivalent to sine divided by cosine. So these two are equivalent. So I can totally, if I see a tan, I can substitute sine over cosine. And then since tan and cotan are reciprocals of each other, that means that the reciprocal of sine over cosine is cosine over sine, which is cotan. All right. And then the last bit is Pythagorean identities. There's a couple of problems in here where you guys discover this through work. We're not going to do that with our reduced workload for the at-home learning. But if you guys are curious, you're more than welcome to do it. You'll see it in both 5.6 and 5.7, but we're skipping right over into 5.7. So these are called Pythagorean identities. And the reason why is because if we solved for these, if we discover these, it would be a squared plus b squared equals c squared, essentially, and that's why they're Pythagorean identities. But so this is a new trig identity. So sine squared plus cosine squared equals 1. Secant squared is equal to tan squared plus 1. And then cosecant squared is equal to cotangent plus 1. So these are just identities, just like all of these are, which means that anytime you guys see something that looks like this, you can substitute. Now I'm going to warn you with this module, it is very critical thinking. You're going to have to do a lot of brain work and processing, but I promise you, this is one of those units where it just takes practice, you guys. There are so many tricks and tips that I'm going to show you that it's just going to take time, and over and over and over again, you're going to see a lot of those same things repeat, and you're going to be like, wait a second, I've seen this before. I know how to do this now. So you just have to trust the process. You just have to practice. I know that that's probably going to be annoying for you, especially if you haven't been really putting in much effort or work, but this is a unit where you guys need to practice. And I'm going to be posting a ton of practice on Google Classroom if you want to do well. So I highly suggest that. Let's get into it. So like I said, we are going to be skipping to 5.7. which is on the page that we're starting on, at least, is on page 8. This is the only page that we are doing today. And here is what we're going to be doing. So do you guys see how you see multiple terms, right? Or multiple trigs? What we're going to be doing is simplifying each of these so that it's a single term. So I'm basically going to turn all of this into just one of these. That's it. So the way that we do that is with our little cheat sheet here and substitution. All right. So let me show you this guy. And it's going to be weird. It's going to be complicated in the beginning, but just trust the process. And I promise it's even going to be frustrating, but we'll get through it. Okay. All right, so starting with this first one. All right, so I see a cotan, and I'm gonna go to my cheat sheet and try and think to myself, what could I maybe substitute cotan with? So the first thing I see, oh my gosh, I wrote tan. Ah! This is cotan. Darn it. I mean, I wrote this part correctly. So cotan equals 1 over tan. All right. So I could replace this cotan with 1 over tan because these two are equivalent. But if I look here, do you guys see tangent anywhere else? No, so maybe that's not the best thing to substitute it with. So where else do we see cotangent? Right below it. Cotangent is equal to 1 over tan, but it's also equal to cosine over sine. Would that maybe be a good thing to substitute in for cotan? Well, I have a sine here. And remember, my goal is to get this into a single term, which means that you guys want to be like canceling things out. That's your goal. To get it into one single term, there's going to be a ton of substitution and then simplifying via canceling or subtracting. So this is all algebra, which is insane, and it's going to drive you crazy if you're not very good at algebra, but this is very algebra based. So let's replace this cotan with this quotient identity. So I'm going to substitute cotan equals cosine over sine. So I'm literally going to take that whole thing, this, and replace it for the cotan. Now, I get a bit lazy when I do this, which drives some teachers insane. I don't put the A or I don't put the theta. I just get lazy and I write cos over sine. So if you guys want to include that A, like cotan of A equals cos of A over sine of A, that's totally fine. But just know that I don't do that because I'm lazy. So there we go. That's substitution 1. I'll just do it for now because I wrote that A and that's going to bother me. All right. So here's where we're at. So the only thing we substituted was cotan for this, right? Secant stayed the same and sine stayed the same. Something that may make this a little bit more visible to you guys is putting these over 1. So these are all fractions being multiplied. This kind of takes us back to module 4. So when all fractions are being multiplied, you guys can cancel top with bottom, right? So do you see how I have a sign up here and a sign down here? Well, what is sign divided by sign? 1. So I'm slowly canceling things out. This is great. So what do I have left? I have cosine times secant. All right. But Miss Fisher said I want one single term, and this is not one single term. So what else could I possibly replace here? I have a cosine and I have a secant. Any ideas? Well, secant equals 1 over cosine. And there's so many different ways for you guys to solve this too. If you wanted to go this route, totally fine. You're going to get the same answer. So there's really multiple ways to solve this. So looking at my key is only like one way to solve it out of like 5 or more. So, but I'm going to replace this secant with 1 over cosine because those two are equivalent. So I literally substituted, and that's still being multiplied by this cosine here, which I'm going to put over 1. Do you see what I could do now? Cos over cos divides into 1. Now, not all answers are going to be numbers. Sometimes, like, you could have just gotten secant as your answer if that's in fact what this substituted down to. But that's what it means by a single term. So you're just going to see like one thing, like a 1. Isn't that crazy? We went from 3 trig expressions being multiplied together into 1 using substitution and canceling. Algebra. Algebra brought this from here to here. That's so cool. All right, let's try the next one. A little bit different, but let's kind of brainstorm again, maybe what we could replace things with. So usually like the starting point is what's most difficult for a lot of people. But I see a cosine and a cosine, and then I also see a cotangent. Does this equal something that includes both of these? Because remember that my goal is to cancel things. So if I can cancel, that means that I want a lot of the same trig ratios. So we're actually going to be doing something similar to the previous problem. Cotan equals cosine over sine. So why don't I substitute cosine over sine for cotangent? All right. So I'm going to take this cotan and replace it with cos over sine. But it's still being added to sine, and it's still being multiplied by cos, and I'm going to add an over 1 here. All right, so nothing cancels right now, but that's okay. I have a lot of the same stuff, which is kind of a good thing. Let's try and simplify this down a little bit. Why don't we multiply, again, lots of algebra, multiply these two fractions. So this is sine plus cos times cos is cos squared, right? Just like x times x is x squared, or 3 times 3 is 3 squared, which is 9. So it's no different. Cosine times cosine is cosine squared. And that's all over sine times 1, which is sine. All right. Then people usually get stuck, but if you see a fraction, try and make other things fractions, just like I made this cosine a fraction, just like we made these a fraction. So if you see fractions, it's usually a good idea to make something else a fraction. So now I'm here. How do we take two fractions and add them together? How do we add fractions, guys? Least common denominator. So if this denominator is a sine and this denominator is a 1, what do you think our least common denominator is? Sine. So I'm going to multiply this guy by sine, and now my two bottoms are the same, right? So now I can add them together But in order to do this legally in math, I need to multiply both top and bottom by sign. Okay, with me? All right, let's move up here. Simplify this a little bit. So sine times sine is sine squared, and that's divided by sine times 1, which is sine. And it's being added to this whole thing. We didn't have to do anything to that fraction. So the whole purpose of doing this was so that we can add two fractions with the same denominator, right? So when you add two fractions, remember that the denominator stays the same and you add straight across. So this is just sine squared plus cosine squared. All right, I'm stuck again. Now, please don't be tempted to go in and cancel these signs. Just like in module 4, this is a no-no. You guys can't do this because of this plus sign here. If that was a multiplication sign, you could cancel, but it's a plus sign. So this is considered one thing. I can't cancel those. It's literally saying that if you cancel these, then cosine squared was never divided by sine. But it is. So usually a good thing to do when you're stuck, go to your cheat sheet. So do you see anything that you could replace something with? I see a sine squared plus a cosine squared. Do you see that anywhere on your cheat sheet? Ah, what does sine squared plus cosine squared equal? 1. So does that mean that this whole numerator is equal to 1? Yeah. So I can, by substitution, using Pythagorean identities, I can substitute my numerator, sine squared plus cosine squared, for what it equals, which is 1. And it's still divided by sine. Oh my God, look at that. We're getting closer, guys, getting closer. What does 1 over sine equal? Do you remember? Or do you still need your identities? What's 1 over sine equal to? I see 1 over sine. What does it equal? Cosecant. And I'll add the a back just to be nice. So we went from this to that. That's one single term. Is that not the coolest thing ever, you guys? When you go from this to that, it's amazing what you have learned in Math 3. Trigonometry, trig identities. Super cool. All right, how are we doing? We need more practice, so don't stop now. We got to keep moving. We have 3 more. That's why this is a whole classwork, because these take a long time. Let me see. Some of these can get pretty hard, actually. So if you want to, pause the video and maybe attempt number 5. And then when you get stuck, if you just cannot figure it out, come back and watch the video. And then if you like a light bulb goes off or you get a hint and you can keep going, do it. Pause the video again and try again, because trust me, you guys need this practice. So just watching me do it is not helping you learn. So I really need you guys to try this on your own and actually do it. Don't be like, okay, Miss Fisher, and not pause the video. So please try to do this on your own. All right. So attempt this first. If you get stuck, come back and watch. And then as soon as you kind of get a little hint or a gleam of light comes through your beautiful brain, pause it again and keep trying. Okay. You have to keep trying. Put in like 20 minutes of effort of your own time today. Okay. Same with on homework. You guys need this practice. And guess what? Tonight's homework is literally only 4 problems. It's not that hard. So you can do this, all right? So go ahead and pause the video and then push play if you need some help. Here we go. All right, so this one's kind of complicated. It's not the best strategy, but sometimes if you're completely stuck, sometimes it's really nice to just try and turn everything into sines and cosines. So I'm going to take this cotan, and just like with previous 2 problems, I'm going to replace cotan with cosine over sine. Then I'm going to subtract. Can I replace cosecant for anything that has this? Cosecant equals 1 over sine. So why don't I replace cosecant with 1 over sine? And then I'll just rewrite this other one. I'm going to cover that up for now. What do we have here? Two fractions with the same denominator. You can do this. Pause the video and go. Try it out. So how do we subtract two fractions? They need an LCD. These ones already have an LCD. So let's combine them. I'm going to put this over 1 just because I told you that trick. If you have a fraction, make the other one a fraction. It just makes it easier. So if you got stuck here, again, you have two fractions. How do you multiply two fractions? Pause the video. Go. Try it. This is cosine minus 1 times cosine plus 1 all over sine times 1. All right, if you came back because you got stuck, here's your hint. This should look kind of familiar to you, especially after me drilling it into your brain with IM3. What if I gave you this? What would you want to do? What should you do? This is in factored form, so let's multiply it together either using FOIL method or the box method. These x's are just cosines. You can still have cosine squareds. So go ahead and multiply those out. Pause the video, go, try it on your own. Zoom out a little bit. So when you multiply this all out, you get cosine squared, cos times cos, and cos times 1, then cos times -1, and -1 times 1. That's what I have for my numerator. And it's all over sine. Stick to the numerator. Does anything simplify? Does anything cancel? Remember, this is algebra. What's going on here? Cos minus cos. What's cosine minus cosine? What's 2 minus 2? What's x minus x? Anything minus itself is 0. It cancels out. What does that leave us with? Cosine squared minus 1 all over sine. All right, next up. We can manipulate our Pythagorean identities using algebra. So do you guys see how there's a cosine squared and a 1? Whenever you guys see like a trig squared and a 1 or two trig squareds, it's gonna be a Pythagorean identity. Because do you see how these are all 1s? And then I have two trig squares in each equation. So that's kind of like your hint there. That's something to look out for in the future. Now that you've seen this once, you're gonna know what to do because I'm giving you that tip right now. So I see a cosine squared and a 1. This very likely means that we're gonna be using a Pythagorean identity. Which one? This one. This has a cosine squared and a 1. Now, how can I change this to make it look like this on one side of the equation? I'm looking for cosine squared minus 1. I don't see that exact thing over here, right? So here's cosine squared. How am I going to get that minus 1 to appear? Not by magic. You can subtract this 1 to the other side. Boom. I now have cosine squared minus 1, which is what I want, right? But it's not by itself. There's this sine squared being added. So what do I need to do with that to get this by itself? Subtract it over. That's what I mean by manipulating Pythagorean identities. So this is a Pythagorean identity, but guess what? So is this. These two are equivalent. cosine squared minus 1 equals sine squared. I got that from my original trig identity. So can I substitute cosine squared minus 1 over here with something I see here? Oops, I forgot my negative sine squared. Yeah, cosine squared minus 1 equals negative sine squared. So I can replace this cosine squared minus 1 with a negative sine squared. That's substitution. They are the same thing. So that whole numerator is becoming negative sine squared, and it's divided by sine. What can I do now? This would be like seeing x squared over x. What does that equal? Just x. So what's negative x squared over x? Negative x. So what's negative sine squared over sine? Negative sine. And that's your answer. So we went from this long thing to one single term. It's so crazy, and it's a lot of critical thinking and processing skills and algebra that you guys can do this with practice. All right. So I bet you anything, if I were to give you another one so similar to this, you would see something like this again and be like, oh my God, I've seen that before. What did I do? And you would get here and here, and you'd say, oh my God, I've seen this before. What did I do? And it just repeats over and over and over again. I can't trick you on the test because I'm literally going to show you all of the tricks before the test. Okay. So you just have to try. Please put in some effort with this module. I'm begging you. Okay. We got 2 more, guys. We can do this. Number 6. Who's with me? All right. Number 6 looks a bit crazy. So let's try and think of this as something maybe we're more used to seeing. If this was let's say, solving, how would you guys solve this? What's the first step to factoring? GCF, GCF. So we need to pull out a greatest common factor. What can you divide both of these by? What is the biggest thing that they have in common? An x squared. So it's like reverse distributing. So what's x cubed divided by x squared? X. And what's x squared divided by x squared? 1. So I distributed that out using greatest common factor. That's algebra. So guess what we can use here? Algebra! Told you, crap load of algebra coming your way. So this is cosine cubed plus sine squared times cosine. So does this and this have something in common? Do they have a greatest common factor? Yes, they both have a cosine. So I can divide both of these by 1 cosine and pull it out here. That's my greatest common factor. Now what's left over? Cosine cubed over cosine is cosine squared. Cosine over cosine cancels to be left with sine squared. If you see something, pause the video and go with your thought. You can do this. Do you see something that looks familiar? Do you see something that's on your cheat sheet? What's cosine squared plus sine squared? Sine squared plus cosine squared, same thing. 1. So we can replace this whole thing with a 1. Boom. What's cosine times 1? Cosine. 1 single term. So here are all the strategies that we've done in just 4 problems. We've done substitution or replacing. We've done fraction work. So how do we add 2 fractions? How do we subtract 2 fractions? How do we multiply fractions? We've done a lot of that. Greatest common factor. We've seen that. And then we've also seen canceling. There are so many algebra tricks that you guys know how to do when it's seen in simplest form, but just because you're seeing it like this, it just freaks people out. But you have to trust the process and you're gonna get through this. Okay, last one. Remember all of those things: replacing, substituting, division, as in like fractions, how do you add fractions, divide fractions, etc. Using your cheat sheet, using GCF, all of these things. Maybe try and pause the video and try this one on your own, okay? Can you do this? This one is a bit crazy. Sometimes when I'm given a fraction, because we actually weren't given a fraction in any of these other ones, I actually like to break it down and focus on like just the numerator for a little bit. So let's ignore the denominator. Let's just focus on that numerator. Let's try and clean it up a little bit. Can I replace anything for cosecant? Cosecant is 1 over sine. I have a fraction. What was your trick for fractions? Make the other one a fraction. How do I add two fractions? LCD, least common denominator. Now that we have the same denominator, how do I add two fractions? Straight across. Sine plus 1, all over sine. Do not attempt to cancel that out because of this plus sign. All right, so that's my numerator. Let's pause there for a moment. I don't really see anything else I can replace currently. Let's go focus on our denominator. What do you want to replace? Maybe cotan? We had a lot of cotans, huh? So cotan is equal to cosine over sine. So let's replace it with that because I already have a cosine. And then I have sines over here, so that's a good sign. All right. What's been your trick? What's been the little tip for you? If you have one fraction, what should you do here? Make it a fraction. And how do you add two fractions? LCD. So do you see how like a lot of the same things repeat? Like this is a completely different problem, but so many things repeat. All right, same denominator. I add across sine times cosine. So I'll just say sine cos and then plus cos. That's my denominator. So if this is my numerator and this is my denominator, instead of writing this as a double fraction, let's write it like this. Numerator divided by denominator. So this is the same thing as this. I know I made it a lot bigger, but at least I see a lot more of the same type of trigs, okay? Okay, pause the video if you think you have like a little bit of a hint, but this is two fractions being divided. How do you guys divide fractions? KFC, go, pause the video, go, try it out, let's go. So KFC is keep, change the sign to multiplication, and then flip the second fraction. So reciprocal. All right, hopefully if you pause the video, you've seen what to do, but what do you guys see? What can we do? What can we do? Cancel, sine over sine, cancels out. Boom, we're getting this smaller. That, remember, that's our goal, right? Is to make this into a single term. So we're trying to get this smaller. Let's simplify. I'm left with this as my numerator. All right, and then here's my denominator. if you got stuck here, like, what do I do? Again, think about all of the tricks that I've shown you. What was the trick that we did in the previous problem? GCF. Do it. Go for it. Pause the video. You can do this. Go. What's next? Denominator. What do they both have in common? A cosine. So is that a GCF? Heck yes, it is. So let's take out that GCF, and what's left over if you divide this by cosine and this by cosine? That's here. What's left? Sine plus, what's cos over cos? 1. What's on top? Do you see it? Tell me you see it. What do you do? Do you see it now? What can you do? Cancel. Top divided by bottom, same thing divided by the same thing is equal to 1. Boom. What's left, guys? We're almost there. One more step. 1 over cosine is not our final answer. Single term. What is 1 over cosine? You got this. Secant. Boom. Done. So do you see what I'm saying by, like, this is complicated stuff? It is. But as we worked through, there was a lot of rollover. A lot of the same tricks that I have taught you popped up again. So I want you guys to remember this. If you look at that cheat sheet on the bottom, the one that I posted on Classroom, there's rules and strategies. Look at the strategies. So number 1 says replace any terms for ones you already see. So that would be using the cheat sheet. We did a ton of substitution, a ton of replacing. Number 2 says cancel and simplify when you can. So when you come across fractions, we were able to cancel, right? Cancel. Lots of algebra. Number 3 says if you can FOIL, FOIL. That's what we did over here in the third problem. We multiplied these two together to get to here. Number 4 says if you can factor, then factor. That would be like doing this in reverse. Look for those Pythagorean identities. So that would be like when we were in the second problem, number 4, right here. You saw 2 things squared. Or where was the other one? We saw another one here, 2 things squared, those equal 1. This was the tough one to point out right here. We saw a something squared and a 1. That was a Pythagorean identity. So these are the clues to look out for. So that's what I'm talking about. On that cheat sheet, the strategies. Number 6 says add fractions by using a common denominator. Guys, how many common denominators did we use on this single page? So many. So a lot of these things get recycled, all right? So you have 4 problems tonight for homework. That's it. You can do this. So please do your best not to look at the answer key, and do your best to look through the strategies, look at what we did here if you even need to. So like, please look at the cheat sheet and the classwork before you try looking at the homework key, all right? So homework tonight is RSG 5.7, and you're gonna do only numbers 5 through 8. And this is on page 7 of the RSG packet. So that's literally 5, 6, 7, 8. 4 problems. You can do this. No complaining. All right, guys. Have a wonderful day.